today we're going to look at the anatomy of a wave, or parts of a wave. So we're going to look at a transverse wave, which we know is a vibrating up and down particles that travel perpendicular to that, so they travel horizontally. What we're going to look at are some parts of the wave, and the first part is this distance right here at letter A. The distance from your resting position to your farthermost vibrating position is called the amplitude of the wave. Where the amplitude is the greatest positive direction is a crest. Where the amplitude is greatest in the negative direction is what we call a trough. So again, rest position is the dotted line. Crest is where it has the maximum amount of positive displacement. A trough is where it has the maximum amount of negative displacement. Amplitude, the maximum amount of displacement. It could be up or down from the rest position. And then the wavelength is the length of one complete wave cycle. So let's go back here and look. Wavelength. So a wave cycle would be one crest to one crest. This would be one wavelength. So with longitudinal waves, the particles in the medium, as you recall, move back and forth, and then the wave goes in that direction. So they stay parallel to each other. So you got here, where the wave particles are close together, that's called a compression. And then where the wave particles are spread apart is called a rarefaction. So we have compressions and rarefactions in longitudinal waves, as opposed to crests and troughs, as we see in the transverse waves. So a compression is a point where the longitudinal wave has maximum density, where everything is compressed together. A rarefaction is the longitudinal wave that has the minimum density, where they are more spread apart. Okay, so if we wanted to, I guess, find the wavelength in a longitudinal wave, we would look between compressions or rarefactions. So let's say we look here. If we found the distance between these two compressions, that would be our wavelength. So let's look at some examples here. So we're looking at a wave, and this is the wavelength is given by what letter? Well, wavelength is is one full wavelength, so that would be letter A is our wavelength. And then the amplitude. Amplitude is the distance from rest position. So B is not amplitude because that's the distance between rest from maximum displacement in the positive and negative directions. It's actually two amplitudes. D is what an amplitude is. Amplitude is from rest position to either positive or negative end, which is what we see there. What completes one full wavelength? Again, I want to do from here, from crest to crest, so B to F, or trough to trough. All right. So let's keep looking here. So from B to F, not one of my options. Let's go A to C. A to C, no, because I only see one crest here. B to D, here's B, here's D. That's barely a wavelength. We got from one crest to one trough. A to G, we got here to E to G. That's more than a wavelength. It's 1.5 wavelength, but C to G is. Okay, so it's one full crest, one full trough. We have C to G. That's what a wavelength would be when we look at a wave.